Hello, Richard here, and today I've got a fairly short video for you on the subject of when you flatten a wood plane and you make the sole nice and flat through whatever process you use, does it stay flat? Now, I flattened both of these about a year ago and I've been using them for the past year. These are my two sort of go-to planes. I've got a Stanley number 5 jack plane and I've got a Record number 4 smoother. Both have been hand scraped and they were very, very flat to within less than 1/1000th of an inch. And as part of another video I'm doing on wood planes, which is going to be a bit of a myth buster on whether taking the iron out causes the sole to bend. So should you flatten a plane with the iron in or the iron out? That's coming up. But in the process of doing that, it occurred to me, maybe I should check these planes to see if they're still flat after a year's use. So that's exactly what we're going to do. I've got an engineering surface plate here. This is a block of precision machined granite, which is flat within about a 1/10,000th of an inch or about 2 microns. So what we're going to do is a really quick and easy way of checking if something's flat is we're going to spread some engineer's marking blue on the surface plate, and then we'll take the plane, we'll rub it in the blue, and high spots will turn blue, low spots will stay shiny. And that will give us a really quick and easy indication as to how flat this thing still is or isn't. If it isn't flat, then what we'll do is we'll go a little bit further and we'll actually measure it. We'll actually measure exactly how far out it is. And that'll give us an exact measurement as to how far out a plane sole might warp or distort over the period of about a year. So let's get some blue on the plate and we'll see how flat these are or aren't. Okay, so let's begin with the Record number 4 smoother and we'll see how that does. You can see the scraped finish on that. That's had a bit of use now. So let's see how flat that is. What we'll do is just pop it on the surface plate. Now bear in mind I've got the iron backed off on this. The iron is pulled up into the body, so it's not going to be, we're not going to be planing the surface plate, hopefully. Right, so let's just give that a go. Just put it down, give it a little move around so it can pick up some of the blue. I'm not pushing down on it, I'm just letting it move under its own weight. And then we lift it straight up. And there you go, that's quite a nice looking pattern we've got going there. So what you can see, where you can see blue, that's flat, so that's the same level as the surface plate. Where you can see shiny metal, that's where it's basically hollow. So looking at it from above, the blue is the high spots and the shiny bits are the low spots. So you can see we've got a bit of a low spot just here. It's a little bit low in here maybe, a few points where it's touching. And it's low all the way through here, but there are little touches of blue. Hopefully you can see those, there's little flecks of blue. So that does mean there's contact in amongst here. So it's gone slightly low in a sort of hollow there and low slightly down this side. So that's that one. That isn't as flat as it was, but we don't know how unflat it is, if that's even a word. So what we'll do, we'll check out the jack plane in a minute. And after that, we'll get this rigged up so we can actually measure just how low that is and put a number on it. Because if it's not very much, which that might only be 1/2,000th of an inch out on that spot. If it is, doesn't matter at all. No need to do anything. Right, so let's have a look at the jack plane. Okay, what I'm going to do, I'm just going to roller out the blue a bit more on here. Even it out a little bit when we roller. Then we'll take the jack plane, just make sure it's clean. Put that down on the surface. Give that a move around. And there we go. Now that's a slightly different story there. Let me get it so you can see it. So that's looking really quite good. I would say dead flat on the front of the sole where it was, dead flat behind. There's a slight hollow here, a few little touch points there, a few little contact points in there though, so it's not completely hollowed, and good contact there. So that's really flat. That's really held its flatness really well, which surprises me. I'd have thought the smaller plane would have been more rigid and would have held its shape better. Anyway, you can see we've got a little bit of a low spot in here. So what I'll do is I'll get set up so we can actually measure just how low this is. And I don't think it'll be very much at all, but still, it'll be good to put a number on it. I've rigged everything up to take a few measurements, and I'll just talk you through the setup here because it's a little bit on the Heath Robinson side. If you're of a precision engineering disposition, you might want to look away now because this isn't pretty. Remember, this is engineering at home and we have to improvise. This isn't engineering at NASA. So what we've got is we've got a cylinder square, which just happens to be a tool object that I can rest the side of the plane on here. And then over the other side here, we've got a surface gauge, and the curved end of the scriber is supporting the plane on the other side. So that's 2 points, 1 point here and 1 point there. And with a fine adjuster on the surface gauge over here, this knob here, I can tweak that up and down, and this will actually level the plane this way. Using this test indicator, which is on a base here, I can sweep this around, and I'll show you the dial in a minute. You can't really see it from here, but I can get this to read 0 at this point, and then I can sweep it over to here. And if it still reads 0, then I know that the plane is dead parallel at this end with the surface plate. Down the other end here, you probably see I've got my nice new height micrometer, and I'm completely abusing this for a purpose it was never intended for. Well, maybe it was. But I'm using this as a kind of like precision jack. So I've got the other end of the plane resting on this height micrometer, and when I turn the knob on the top, it'll actually raise these discs up and down by precise amount, so I can level plane that way. I can take the test indicator and I can sweep it all the way down to the other end, and if I have 0 at that end, I know the plane is all dead level with the surface plate. Then any readings that I take by sweeping it to other points, I can look on the gauge and see how far up and down it is. So I'll bring you in from above so you can see what's going on, and we'll just measure how out of flatness this plane is. Right, I'm hoping you can see that. This just should be in view here on the gauge. You can see that that's on 0, so that's at this end of the plane. And then we'll move it carefully across the other side. It does vibrate a bit on this, which is a bit of a pain. And over here, you should be able to see that on the other side, we're still on 0, so that's level. Now we'll carefully sweep towards the back. So again, it's going to vibrate a little bit, unfortunately. So hopefully you won't hear that too much. Okay. And then down at this end, you can see there, we're on 0. So we've got 0 on 3 points there, here, and here. So that means that the plane is level according to the ends of it, the corners. So what we can do now is we can sweep the gauge towards the middle, because we knew that we had a bit of a hollow here because it didn't pick up any blue. So let's just sweep along to there and see what the gauge does. And you can see it hasn't moved much at all there. So there we've probably got about minus 1/2 thousandth. Each division on here, so between the lines, is 1/1000th of an inch, and the dot in the middle is 1/2 thousandth, or 5/10,000ths of an inch. So there you can see we've got a hollow just under about probably 1/2 thousandth of an inch, which is absolutely fine, nothing to worry about at all. So this one is looking like it's actually pretty flat, pretty usable. All right, let's get set up to test the other one, the record number 4 smoother, and we'll just see how far out that one is. Right, that's the number 4 set up, ready to measure. And we're 0 at this end. We'll just come up to the other end, and I'll take a little shortcut on this flat bit here, rather than jog the indicator too much. And then up here, we're about on 0. And then we sweep over to the other side. We should be still on 0, near enough. That will do. Okay, so let's just take a little bit of a sweep along the plane. And on this edge, I believe this edge looked like it was a little bit low, but there you can see that's still within, well, smack on, really. That's hardly moved at all down that edge. And here, again, it's within 1/2 thousandth easily. And if we just look at the front there, now there was a little low spot here I seem to remember, so let's have a look at that. Yeah, there's a little sort of 1/2 thousandth hollow there, hardly anything. And if we come down this edge, oh, I fell off the side of the surface plate then, that was my fault. Hopefully I haven't upset the 0 too much. Let's just check we're 0'd at this end. So yeah, near enough, that'll do. So let's just sweep down this edge a little bit. As I say, I've got limited space, so I might fall off the edge a bit. But that's showing, that went down to about minus 1/2 thousandth. And in the middle, again, that's pretty spot on, really. It's a little bit high there, maybe. But yeah, hardly anything at all, really. So there we go. That's another one that's sort of, it's changed shape. We've been able to detect that it's changed shape, but it's changed by such a tiny amount. It's still well within spec for a plane. According to international standards, the standard of flatness for a wood plane is within 1/1000th of an inch over its entire surface area. So within about sort of 2/100ths of a millimetre thereabouts. This is certainly well within that. So unless you want to be making sort of transparent shavings, then this is still more than up to the job. So there you have it. Does the flatness of your plane change over time? Well, yes, it does. Does it change by much? Probably not. These have been used moderately hard. I don't use these every day, but these are both my go-to planes. I've used them a fair bit. And as you can see, they both retain their flatness to within about 1/1000th of an inch or 100th of a millimetre. So yeah, hopefully that'll give you an idea of what to expect on the flatness of a plane. There are lots of other things that can affect the flatness of planes as well. And that's going to be the subject of the next video. So stay tuned for that.